Hello, in this video I will do an ASVAB math knowledge practice exam. So let's begin, but this will be timed, but um I'm gonna take my time because I need to show you every step. But if we run out of time, it's not because yeah. Okay, let's start with question one. So question one says if the area of a square is 625, what is this length of its side? So if you want, what you could do is draw an image. Whoops. So what do we know about squares? We know in a square, all sides are the same. Let's see, what else do we know about a square? A square is the area of a square is length times width, or you can also say because all the sides are the same, you can also say area equals side times side or area equals side square, right? A square. So if we know the area, so if you use this formula and you replace A with 625 because that was given, and you want to find just regular s, you can get rid of this power 2 by taking the square root of both sides. And what is the square root of 625? Um, I think it is going to be, so what number times itself twice gives you 625? I think that is going to be 25, right? 25 times 25 is 625. Okay, so yeah. Um, yeah, I mean, even without a calculator, you know that if you try 30 times 30, that's 900. So that's a little, so it has to be between A and B, between A and C, right? So it's 25. Okay, let's move on. Question two, the slope of the line is shown. Um, yeah, so what is this? They're asking you, what is the slope? So, um, sometimes you can see it really good. What is a slope? It's basically the rise over the run. Sometimes you can eyeball it, right? It looks like you can, if you start at this point and you rise one, two, so your rise is two. Wait, so you see, I started at this point, and if I rise two, one, two, and then I run one, my rise is two, my run is one, so my slope is two. Now, if you sometimes it can be a little bit difficult. Sometimes you can't really tell. So what you could do is pick 2 points on that graph, two exact points on the graph. So we have an exact point here. That point would be labeled as 0, comma -3. And I need another exact point on the graph. So it doesn't matter as long as it's an exact. So it looks like I see a point right here. That's the exact. So that's 2, comma 1. And then what I'll do next is use a slope formula. So if you recall, the slope formula is y2 minus y1 over x2 minus x1, right? So I pick 2 points and I'm going to label this one x1, y1, label other point x2, y2, right? So my y2 is 1 minus my y1 is -3, so minus a minus 3. X2 is 2 minus x1 is 0. Okay, put it all together. On the top, what's 1 minus a minus 3? But we know that two negatives becomes a positive, so that's 4. And then on the bottom, what's 2 minus 0? 2. What's 4 divided by 2? 2. So that's how you find the slope. So if you can eyeball it, that's perfectly fine. Pick a point, figure out how much you rise and how much you run. Or if it's a bit difficult, just pick 2 points and then just use this formula, right? Pick the 2 points, label the points x1, y1, x2, y2, and then just put in the formula and you should find your slope. Question three. Eight more than twice the number is equal to 50. Find the number. Yeah, how we have to come up with an equation that comes up with this sentence. So let's look at the first part. Eight more than twice the number. So eight more means plus eight to me. Twice a number means two times a number. I don't know that number, so I'll call it X. The word is or equal is going to equal and then 50. Right? So 8 more than twice a number is equal to 50. So it's really translated as 2x plus 8 equals to 50, right? Then what you do is find that number. So to find that number, you just simply look for x. So I'm going to subtract 8, 2x, and then 50 minus 8 is 10 minus 8 is 2, and then 4, divide this by 2, and you get 42 divided by 2, which is, without a calculator, it's 2, and this is 1. Okay, so that number should be 21. Okay, any questions? I mean, oh, yeah, this is pre-recorded video. So yeah, 21. Question four, subtract. So we have this polynomial 4x cubed minus 5x plus 2 minus 2x squared minus 4x minus 3. So all you got to do is when there's a minus in the middle, if there was a plus, you wouldn't do anything. You would just combine like terms. But because we have a minus, let's FOIL out. This minus is like an invisible -1. So FOIL out that minus. So that's negative 2x squared. A negative times a negative is a positive 4x. And a negative times a negative is positive 3. This, we have done nothing. So just bring that down. And it's all about collecting like terms. So start with the highest power. My highest power is 4x cubed. My next highest power is negative x squared. I don't see any other x squared, so bring that down. And then my x's. So I have a negative 4x and a positive, I mean negative 5x and a positive 4x. It's negative 1x. And then my constant is 2 plus 3 is 5. Okay, so this should be our final answer. Let's see if we have it. 4x cubed minus 2x squared minus x plus 5. I think it's the first one, right? 4x cubed minus 2x squared minus 1x plus 5. Yep. This one simplifies. So what you could do is on this one is we have 15a cubed b squared minus 10a squared b cubed all over 5ab. So what you could do on the numerator is factor out a GCF. So we have two terms here. If you want, I can write it out again. So what we'll do is factor out a GCF on the numerator. So if you look at the numerator, let's see. Let's start with the letters B. So over here in this is my first, this whole thing is the first term, and then this whole thing is one term. So if you look at our B's, we have a B2 and a B3. What's the largest amount of B's you can take out evenly? Yes, two B's or B squared. Now what about our A's? We have three A's or A cubed, and we have two A's, A squared. What is the largest amount of A's we can take out evenly? A squared. And then our constant is 15 and 10. What is the largest number that they're both divisible by? That's what I tell my students. Um, 5, yes. Can we go any higher? 10. Unfortunately, 15 divided by 10 doesn't come out. nicely, so we can take out a 5. Okay, now we kind of, this is our GCF, so we can't change our problem, so we have to go back to, what do we have to multiply this whole thing to get the first term, 15a cubed b squared? Well, I'm going to need a 3, because 5 times 3 is 15. How, do I need any more a's? Yes, I need one more a, because remember when you're multiplying exponents, you add the powers, right? A2 times a1 is a3. Do we need any more b's? No. So let's move on to the second term. So what do I have to multiply this to get negative 10a squared b squared? A squared b cubed? Well, I'm going to need a minus 2. And then I don't need any more a's, but I do need one more b. And it's all over 5ab. Now simplify. So 5 divided by 5 cancels. A squared over a1. What happens to that? Well, when you're dividing, you're subtracting. So 2 minus 1 is 1a. And then b2 minus b1, that's b1. And then you're still left with this. And you don't see our answer because they did one more step. They kind of FOIL this out. So what's AB times 3A? Well, that's 3A squared B. What's AB times negative 2B? That's negative 2AB squared. So what answer is that going to be? The first one, right? 3A squared B minus 2AB squared. Right? 3A squared B minus 2AB squared. The angles of okay, question 6. The angles of a triangle are in the ratio of 2, 3, and 4. What is the measure of the smallest angle? So you can draw an image. It doesn't say if it's a right triangle. It doesn't say if it's obtuse. Um, well, it's definitely not a right triangle, but you can call this angle 2x, and then I can call this angle 3x, and then I could call this angle 4x. I wouldn't just say 2, 3, and 4 because that doesn't represent our angle. This is just a ratio. And what do we know about a triangle? Well, we know that the sum of a triangle adds up to 180, right? So you could say 2x plus 3x plus 4x equals 180. Then what I would do next is find the x because you want to find the smallest angle. So I think this, let's call this angle 1, angle 2, angle 3. I think angle 1 will be the smallest, right? So go ahead and solve your x. So what's 2x plus 3x plus 4x? That is 4, 5, 6, 7, 8, 9x equals to 180. Solve for x, you're good. Divide this by 9, divide this by 9. And you get 180 over 9 is 20. And then this is my smallest angle, so it's 2 times 20, which is 40, right? And if you don't believe me, what's the other one? So angle 2 would be 3 times 20, which is 60. That's 2, not the large, smallest. And then the other one is 4 times x, which is 80. So it looks like 40 will be the smallest. So yeah, it looks like we're gonna run out of time because I kind of started this earlier. I should have paused the video, but it's gonna stop and then it'll give us, it's okay. But yeah, this one will be 40 degrees, will be the smallest. Okay, question 7. In a standard deck of playing cards, an ace of spade is drawn and not replaced. What is the probability of drawing another ace from the deck? So this is a probability problem. So if you to play cards, I'm not really familiar with cards, but I do know that in a card, a standard deck has 52 cards, right? I looked this up, but I'm not really a card player. But yeah, a standard deck has 52 cards, and what we know it says that when one ace is drawn and not replaced, there are 51 cards and three aces left. Wait, so there's 52 cards, and then there's also four aces, right? So in a standard deck, there's 52 cards and four aces. Now they're saying that an ace of spade is drawn and not replaced. So what that means is when one ace is drawn and not replaced, there are 51. There are 51 cards and only three aces are left. So what is probability? So probability is equal to the number of remaining aces over the number of remaining cards. Okay, so that would be, so the number of remaining aces is three, right? You originally had four, but one ace is not replaced. So that means you have three remaining aces. And then um instead of 52 cards, because you took out one card, you're only left with 51. Okay, so 3 over 51 is our answer, but it can be reduced by 3. So that's 1 over 17. Okay. So yeah, yeah, if you don't know about playing cards of decks, we know that there's 52 cards in a deck and four aces in one deck. Question two, how many seconds are there in 2 hours? So how we do this is it's kind of like you may set it up kind of like stoichiometry from chemistry. So we start with 2 hours, and then on the bottom we have 1 hour, and then on the top we have minutes. So we know that 1 hour there's 60 minutes, but then we have to convert it to seconds. So on the bottom you put minutes and then seconds. So we know that in 1 minute there's 60 seconds. And when you put it all together, 2 times 60 times, well, the units disappear, right? The hours cancels, the minutes cancels, and then you're left with seconds. So it's 2 times 60 times 60. Um, well, without a calculator, I know that 60 times 60 is 3,600, and then times that by 2. Oh, yeah, we ran out of time, but it's okay. We still can finish this because, um, oh, hold on. Give me 1 sec. Hold on. Okay, so Yeah, we have to start again. Wait, we can start. We did this one already, right? We did that one. I know we did that one. We did that one. Oh, here we are. Question four. How many seconds are there in 2 hours? So let's just continue. Let's just start again. So we know we're going to put 2 hours here, and then we're going to put hours on the bottom, and then seconds on the top. No, not seconds, minutes, right? And then minutes on the bottom, and then seconds on the top. So we know that in 1 hour there's 60 minutes, and in 1 minute there is 60 seconds, right? So when you put it all together, so when the units disappears, the minutes cancels, and then the what is 2 times 60 times 60? Well, 60 times 60 is 3600 times it by 2. 0, 0, 6 times 2 is 12, carry the 1. 3 times 2 is 6. That's 7200. And then there you go. Okay. We did this one already, remember? Yeah, so we can skip that one. I'm just skipping the ones we have already done. Uh, I don't know if did we do this one? It's okay, I'll do it again. So when you're subtracting polynomials, if there was a plus in the middle, you wouldn't have to do anything. You just combine like terms. But there's a minus right in the middle. You gotta distribute that minus. So this is an invisible -1. So -1 times 2x squared is -2x squared. -1 times -4x is +4x. -1 times -3 is +3. This stays the same, so it's just 4x cubed minus 5x plus 2. Then it's all about collecting like terms, so my highest power is 4x cubed. The next one is the -2x squared. I don't see another -2x squared. The next one is -5x and 4x, which is -1x. And then the constant is +3. Whoops, no, no, our constant is 3 plus 2, which is 5. Let me double check. So 4x cubed, -2x squared, -5x plus 4 is -1. Yes, that's correct. So which will that be? -2x squared minus x plus 5. This one. 4x cubed minus 2x squared minus x plus 5. Yeah, we done this one. The area of a square is 625. Yeah, we done that one. This one we done already. 8 more. Yeah, I'm gonna skip that one. This one we have not done. So question 9 says, what percent of 5/6 is 1/2? So what always means our unknown, x. Percent, you can write percent as two ways. You can write it as a decimal. You can also write it as a fraction, meaning you put it over 100. Of always means multiplication, so I'm going to use parentheses to represent multiplication. 5/6, and then the word is equal to 1/2. And then you just solve for x. So over here, what's x over 100 times 5/6? Well, x times 5 is 5x. 6 times 100 is 600 equals to 1/2. And then go ahead and you can cross multiply. So 2 times 5x is 10x. And then 1 times 600 is 600. Solve for x, you're going to divide this by 10. Divide this by 10. So that is 60. And they want it as a percentage, so just put the percentage sign, so 60%. Question 10, how many distinct prime factors are there in 180? So they basically want you to figure out, do the factor tree, right? So 180 is definitely not prime. So I'm going to make a factor tree, and then I'm going to circle my prime numbers. So what two numbers multiply 180? It could be any number you like. We could do 10 and 8. Uh, hold on. I was just looking. Yeah. What two numbers multiply 180? It could be any. So I'll do 18 and 10. None of these numbers are prime. Remember, a prime number can only be times by 1 in itself. So an example would be 3, because what two numbers multiply 3? Just 1 and 3. Another example would be 5. What two numbers multiply 5? Just 1 and 5. So those are prime numbers. So 18 is not prime, so we have to break that down. What two numbers multiply 18? It could be any number you like, 6 times 3. Now 3 is prime, right? Circle that. 6 is not. It could be broken down as 3 times 2. 10 is not. It could be broken down as 5 and 2. 2 is prime, 5 is prime. Then what you do is look at your prime numbers, the one I just circled, and if you see a repeat, so I see my prime numbers are 3, 2, 3, 5, and 2. Now I see a repeat of 3, so you have a 3 here and a 3 there. That's the same thing as 3 squared. And then I see a repeat of 2, so 2 times 2 is really 2 squared. And then I see a repeat of 5. Okay. Now they're not asking you how many prime numbers we have. They're asking you what are your different bases of your prime numbers. So we may have a repeating base. That's fine. But our three different bases of prime numbers are 3, 2, and 5. So there's a total of 3. That's a total of 3. So that's going to be letter B. Question 11. What is the area of the figure shown? So yeah, we have this shape. I'm not sure what it is, but what you're going to do is you're going to have to like draw two separate shapes. So if you put a vertical line like this, you have two shapes. You have this rectangle and then you have this triangle, right? And here's shape one, here's shape two. So we have a rectangle and a triangle. So what is the area of a rectangle? It's basically length times width. So what is my length of this rectangle? I believe it's 32. What is my width? It is 24. So what's 32 times 24? It is 768. Okay, now let's find the area of this triangle. So what is the area of a triangle? The area of a triangle is base times height over 2. Ooh, we have a problem. Do we know our base? We can find out. Well, if you extend this line, right, and extend this line, this so if this length here is 32 and this entire length from this to this point is 48, what would be this length? 16, right? 16 plus 32 is 48. So so this is also the same length as this. So if you want, you can draw a vertical line and then this creates two triangles. So if we know the area of one triangle, we just times it by 2. So yeah, the base So yeah, I think the base, if you look at triangle 2, this base is going to be 16. And then what's the height of this triangle? Well, we know that this entire vertical distance is 24, and if it's split in half, that means this height is just 12. So the area of a triangle is base times height, so my base is 16, my height is 12, and then all over 2, and let's see, 16 divided by 2 is 8 times by 12, so that's 192. Now you add up the entire area, so this rectangle plus the triangle, so that's 768 plus 192, and that comes out as 960. Okay, let's do question 12. If x is a positive integer, solve for x squared plus 8x plus 20. So basically they want you to factor it and solve for x, right? So the first thing for factoring is you're going to have to get one side 0. So what I'm going to do is move this 20 to the left by subtracting 20 from both sides. So you get x squared plus 8x minus 20 equals to 0. Then what I'm going to do is, because our a value is 1, I'm going to do simple factoring. So this only works if your a value is 1. Okay. So it's also the same thing as the x method, but I think this is much easier. So what I'm going to do is put an x here and an x there, and then blank space, blank space. So what we got to do is come up with two numbers that are multiplying -20, and when added gives you 8. So that's kind of tricky. So can you come up with two numbers that are multiplying -20 and added gives you 8? 10 and 2. And I'm going to use positive 10 and -2 because 10 times -2 is -20, and then 10 plus -2 is positive 8. And then when you actually solve for x, one of your x values is -10, the other one is positive 2. Why is that -10 positive 2? Because what you're doing is essentially setting each parentheses to 0, and then you're solving for x. The same thing here. Okay. So yeah, that it. They're asking you, they only want the positive, so you're going to do positive 2. Okay, question 13. Multiply this. So yeah, you can do two ways. You can FOIL out one at a time and collect like terms, but there's also, I noticed they're practically the same thing. So there's a shortcut you can do. Did you know that 3x minus 2 times 3x minus 2 is the same thing as 3x minus 2 squared? So you can also use this rule. You could do parentheses a minus b squared is equal to a squared minus 2ab plus b squared. Okay. So what we got to do is figure out our a and our b. So if you look at this, what we have, our a is going to be 3x. And then over here, my b is positive 2. So if you put it here, my a is going to be 3x squared minus 2 times a. My a is 3x. My b is 2. And then my b is 2 squared. So clean this up. What's 3x squared? 9x squared. What's -2 times 3x times 2? Well, -2 times 3 is -6 times 2 is -12x, right? -2 times 3 is -6 times by 2 is -12, and then 2 squared is 4. And that is my final answer. So that is letter D. Okay, this one, the sum of square root of 75 plus 2 square root of 27 is. So this one, what you have to do is simplify it. Simplify the radical. So how do you simplify radicals? Well, what I do is let's look at square root of 75 first. What I do first is I know this is not a perfect square root of 70. A square root of 75 is not a perfect square because what two number times itself twice gives you 75? It's impossible. It'll probably be a decimal, right? So what you do is look at the number here. If there is no number, there's an invisible 2. So what that 2 means is we circle pairs of 2's of your prime numbers. So what do you mean? So let's break this down. Let's do our factor tree. So what two numbers multiply 75? It could be any number you want. Let's see. Did I use? I think I used. Hold on, let me look one. I think I did like something with a 5 in it, right? Uh, I don't have it on my notes, but I could do this again. So yeah, what two numbers multiply 75? I think I could do 5 and what else? 75 to not 7, but 5. 15. 5 and 15, right? So two numbers multiply 75 is 5 and 15. 5 is prime. 15 is not prime. It could be broken down as 5 and 3. Okay, so what you do is you look at your prime numbers. Our prime numbers are 5, 5, and 3. Then what you do next is you circle pairs of 2. So I see a pair of 2, so that 5, did you know that this 5 and 5 just becomes 5? And then your leftover prime number is 3, so it's going to be 5 radical 3. Okay, now do the same thing with 2 square root of 27. So what two numbers multiply 27? Maybe 9 and 3. 3 is prime, 9 is not. It could be broken down as 3 and 3. Then what you do is circle pairs of 2. So this 3 and 3 is a pair. So that just becomes 3 and put it outside. And then unfortunately, this 3 is your leftover. Now also don't forget you have a 2 here. So it's 3 times 2, which is 6. So put it all together. What's 5 radical 3 plus 6 radical 3? This is equivalent to saying 5x plus 6x, which is like 6, 7, 10, 11x. But the only thing is our x is not x, it's radical 3. So this is going to be 11 radical 3. So that's letter B. Okay, let's do the last one because yeah. So the last one says find 7/12 plus 5/18. So this is where you kind of need to find out your LCD, lowest common denominator. So if you forget, what you do is you look at the number to find your LCD, you look at the denominator, and unfortunately we got to do a factor tree. So start with 12. What two numbers multiply 12? 4 and 3. 3 is prime. 4 is not. It could be broken down as 2 times 2, or really it's 2 square times it by 3. Okay, now do the same thing with 18. What two numbers multiply 18? Maybe 6 and 3. 3 is prime. 6 is not. It can be broken down as 3 and 2. Then what you want to do next is make so this 3 and 3 just becomes 3 square times it by 2. And then what you're going to do is to find the LCD. So what you're going to do is look at your prime numbers. If you have a repeating base, pick the one with the highest power. So our bases of our prime numbers are 2, 3, 3, and 2. So we do have a repeating base of 2. So we have a base of 2 here and a repeating base of 2 there. So what you do is pick the one with the highest power. So you're going to pick 2 square. And then I also see a repeating base of 3 here and a 3 base here. So pick the one with the highest power, you're going to pick 3 square. And when you put it all together, 2 square is 4, 3 square is 9, and then 9 times 4 is 36. Okay, that is my LCD. So what you're going to do next is find your else. Yeah, go ahead and oops, find your. If my LCD is 36, what do we have to multiply 18 to get 36? I think 2. So multiply top and bottom by 2. Well, so on the bottom, you can always put, you just could put your LCD, which is 36. So over here, I multiply top and bottom by 2. And over here, what do I have to multiply 12 to get 36? 3. So multiply top and bottom by 3. So 7 times 3 is 21. So on the bottom, you could just put 36 because on the bottom, it's always your LCD. On the top, you're going to do some algebra. So 7 times 3 is 21, and then 5 times 2 is 10. 21 plus 10 is 31. Can 31 over 36 be reduced? I don't think so because 31 is already prime. I mean, yeah, it can't be. So it is A. Okay. So yeah, that's it. I'm going to stop here.